Hi there, grade 9s. So today we're going to be going through lesson 4 of chapter 2, and this is going to be exponent laws, lesson 1 of the exponent laws. So there's a couple things that we're going to talk about. This lesson might be a little bit longer than expected, and I apologize for that, but just to try to emphasize exactly what's going on. So one thing that we want to talk about is when we're multiplying numbers together, it doesn't really matter what order we multiply the things in, because we're going to get the same answer regardless. So if we have something like 5 to the power of 4 or times 5 to the power of 2, okay, what does it look like when we break it down? Well, we're eventually going to have 5 times 5 times 5 times 5. Okay, this part here is going to be from here. And then we're going to say times 5 times 5. Okay, and then this part is going to come from here. So technically speaking, what do we have? We have 5 times 5, but it's multiplying by itself 6 times. So we can actually kind of compress it, and we can say 5 to the power of 6. Well, let's see what happens. When we multiplied two powers that had the same base, okay, what happened to the exponents? Okay, the exponents were added. They were added, all right? Now, let's look at what happens when we have this one. So 5 to the power of 4 divided by 5 squared. Or it can look like this. So let's write it out. So we have 5 times 5 times 5 times 5 divided by 5 times 5. Well, what can I do? I can actually try to simplify it. So I can eliminate certain parts. What am I left with? I'm left with this, which is what? 5 times 5, which is 5 squared. So when we're dividing, what's going on? Well, we have our exponents. When we have the same base, our exponents are subtracting each other. Okay, they're subtracting each other. So this is something that we can try to apply a little bit more. So I'm going to give you some questions, and I'm going to let you try to answer them based on kind of this rule that we've developed already. Okay. So when we're multiplying them, we will add the exponent. So let's say if we have negative 7 to the power of 3, and then let's go times negative 7 to the power of 5. Okay. So what's my simplified answer going to be here? So pause it, and then unpause when you're ready. So we're going to have negative 7 times negative 7 times negative 7 3 times, and then 5 more times. So negative 7, 2, 3, 4, 5. Okay, perfect. So just a reminder, when we have bracket beside bracket, that means multiplication. Okay, so it means that we don't have to worry about what symbol might be in between. We automatically assume it's always going to be multiplication. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we can actually say that our answer is going to be negative 7 to the power of 8. All right, which is exactly what it is. All right. Now, what about if we were to have something like 8 to the power of 7 divided by 8 to the power of 4. Okay, some of you might be able to just figure it out based on the rule right away. I'm going to go out and actually write it out as well. Okay, so you're going to get 8 times 8 times 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8 times 8. So then I can actually go and cross some of these off, and I'm left with 8 to the power of 3. Well, 7 minus 3, or 7 minus 4 gives me 3. So that makes sense. All right. So those are kind of the first types of questions that you're going to get. Then you're going to get some where you're going to basically kind of have to answer. All right, or when you've got kind of multiple things going on. So let's start with something like this. All right, we'll do this example here. If you've got I'll do 2 here. Negative 2 to the power of 4 times negative 2 to the power of 7. Okay, so you're going to give me what your answer is. Yeah, so give me what your answer is, but I actually want you to find the actual answer. Okay, so what would the answer be? Not just what would the base and the power be? What would the exponent be? I want you to give me the actual answer. So in this situation, we are going to have 2 times 2 4 times, and then 2 times 2 7 times. So we're going to get negative 2 to the power of 11. Okay. So when we actually go through and do that 11 times, so negative 2 times negative 2 times negative 2 times negative 2, so pause it if you want to calculate what that is, you're going to end up getting negative 2,048 becomes your answer. Okay, negative 2,048. All right, the next one. Okay, and this is where we're going to kind of get into a little bit more explanation. So if we have 3 to the power of 2 times 3 to the power of 4 divided by 3 to the power of 3. Okay, so similar to kind of order of operations, when we're simplifying it, we still have to do it the same way. So we're going to say 3 plus 4 is 6, so 3 to the power of 6 divided by 3 cubed. Now I'm going to actually go and subtract it. Okay, so 3 divided by, or 6 minus 3 gives me 3 cubed. So 3 times 3 times 3 gives me 27. Okay, so that's my answer for that one. Okay. All right, I've got 2 more that we're going to go through. So this is something, it still applies the rule, but I'm introducing one new thing, and that's adding and subtracting when we have powers. So I've got 6 squared plus 6 to the power of 3 times 6 to the power of 2. All right. So when we follow order of operations, we will still do our multiplication first. So I'm going to simplify this. So I've got 6 squared plus 6 to the power of 5. Okay. Now I can't actually go and add these together. Okay, because I'm not multiplying it. What's it going to look like? It's going to look like 6 times 6 plus 6 times 6 times 6 times 6 times 6. Right? So I'm not multiplying. So I can't add the exponents together. So I'm actually going to have to go and solve. So 36, okay? 36 plus 7,776, which gives me 7,812. All right? So that's how we would actually go about finding that one. Okay? So I have to calculate one, and then I calculate the other, and then I will actually have to add them together. All right? I've got one more example similar to this one. And that will be the last one. So this one might look confusing, but it's not if you just follow the rules. Okay? Times 10. And then here we've got negative 10 to the power of 6 divided by negative 10 to the power of 4 minus, oops, this is supposed to be a square bracket, minus 10 to the power of 7. All right, slide my camera over a little bit. Okay, so once again, we have to go through our brackets first. Okay, so I'm going to go through this. So I've got 6 minus 4. So I'm going to have negative 10 to the power of 4 times, I'm just going to put it in brackets, 10 to the power, negative 10 to the power of 2. Okay, so this is multiplication, minus 10 to the power of 7. Now I can add these together, so I get negative 10 to the power of 6 minus 10 to the power of 7. Okay. So when I'm actually going about solving this, if I have negative 10 and I've got 6 zeros, okay, because it's going to happen an even number of times, okay, an even number of times, my answer is still going to be a positive, okay, because of my exponent. So when I'm thinking about my integer rules, okay, if I have a negative times a negative, an even number of times, I'm going to end up with a positive. If I have a negative times a negative, an odd number of times, I'm going to end up with a negative. So I'm going to have 1 with 6 zeros, 1, 2, 3, 4, 5, 6, minus 1 with 7 zeros, 1, 2, 3, 4, 5, 6, 7. I'll put commas in if that tries to help you understand exactly what's going on. So I've got 1 million minus 10 million, and I'm going to end up with an answer of negative 9 million when I subtract those numbers. All right. So if I hope that kind of helps. I know it is a little bit confusing. We'll go over more questions in the Zoom chat. If I can help you out with any other questions, please let me know through Hangouts, and I'll be happy to kind of guide you through that. All right. Have a great day.